So Dominic here? Who's Dominic?
Dominic is the one, black t-shirt.
Okay.
Here. Yeah. I don't know if we'll be able to get like a second minute taker, but anyway, people can join the Etherpad. So, yeah. Shall we?
Yeah.
Shall we start? Okay. Hello. Hello, everyone. Can you hear me? Now is it better? Yeah. Thank you. Okay. Hello. Welcome to the meeting of the 6LOW Working Group. Please make sure that you are in the right room. So my name is Carlos Gomez. This is Shweta Bandari, and we are the new chairs for the 6LOW Working Group. As you may recall, the former chairs, Gabriel and Samita, stepped down a few weeks ago. So we'd like to thank them once again for their work and their help during this time. Our responsible AD is Suresh Krishnan. Today he hasn't been able to attend in person. However, we have Eric who may help today. And we have a minute taker, Dominique, who volunteered. Thank you very much, Dominique. Is there perhaps anyone who would like to be a second minute taker to help Dominique? Thank you. Okay. Well, thank you. Okay, so we have a JavaScript. Rahul, thank you very much for volunteering. And on this slide, you may find a number of pointers to important resources, such as the online agenda, the Java Room, the Meet Echo, and the Etherpad. By the way, I guess Dominique will be, and the second minute taker will be using the Etherpad, so feel free to join the Etherpad and complement what is being written. Okay. Next. Well, this is the Notewell. This is basically a reminder of IETF policies on a number of important topics, so please make sure that you read it carefully. And this is the agenda for today. After the chair's introduction, we'll have a batch of presentations of documents related with neighbor discovery given by Pascal. The first is the status of Working Group LASCOL on address-protected neighbor discovery. The second is the status and publication request of the backbone router document. And the last one is ND unicast lookup and some questions towards considering working group adoption. After that, we have Charlie, who will present the packet delivery deadline time document. Then Youngjun will present the use cases document, the update after the working group LASCOL, and the discussion for the next steps for the document. Then I will present an update of the IPv6 mesh over PLE links draft after working group LASCOL. And then we have two documents that are related with fragmentation. The first presentation will be by Thomas, who will present the update of the minimal fragment forwarding document and the preparation for working group LASCOL. And then we have Pascal again, who will present the status of the fragment recovery draft. After that, Remy will present the status of IPv6 over PLC. So far, are there any comments on the agenda? Okay, so the chairs would like to propose adding one item at the end of the agenda, a very small one, perhaps less than 5 minutes, basically in order to talk about the 6LOW wiki. Okay. Is there any objection to adding this item to the agenda? Okay, thank you very much. And now let's look at the status of working group documents. Since the last IETF, we have yeah, Suresh. Okay, we can read that Suresh is speaking, but we cannot hear you, Suresh.
Hey, can you hear me now?
Yes.
Excellent. No, this is like the NFC document went through IESG eval. Some stuff to fix in there. So I think it'll be good if the authors are in the room, if you can chat with them to see how they plan to resolve it. That'll be really good.
Yeah. So perhaps do the authors want to mention anything on this draft? On the IPv6 over NFC, do the authors want to explain?
Yeah, my name is Youngwon Choi. I'm the author of the IPv6 over NFC. Actually, we had the telechat from of the IESG, and I got some comment and discuss from the IESG chat. And I'd like to thank. Firstly, I'd like to thank for all the reviews from the the IESG, and I have planned to address all the reviews as soon as possible, and I will produce an update draft with the new text about all the comment and discuss. That's all. Thank you.
Okay, excellent. And
Okay, thank you.
that's kind of like not very in nature. That a lot of the NFC related text looks like marketing text. So I think if you need any help from me, let me know. Okay, so I'll help you tone the.
Okay, Suresh, we've heard only some part of what you said, like we can count on your help, and also some comments about the marketing similar text. So that's what we heard.
Try again, so see if it works. So one of the comments was that a lot of the NFC technology text was very marketing type. So do you want me to type in Jabber so Rahul can relate?
Okay, so yeah, we can only partially hear you from time to time. Well, so perhaps if you can write on Jabber.
So Suresh on Jabber, one of the issues was that the technology related text was very marketing oriented.
Yeah.
Yes, I've got the comment about the marketing, and maybe I will have some fully concentration about the marketing text, and then I will update that draft. Thank you. I will ask you something about that. Thank you.
So Suresh has proposed that if the authors want, I can tone it down.
Okay, thank you. So again, since the last ITF, we have a new RFC, it's 8505 registration extensions for 6LoWPAN neighbor discovery. So congratulations to the authors and thanks to everyone involved. Then we've already commented on IPv6 over NFC. Then the next draft is packet delivery deadline document, which was submitted to the IESG. It received a number of reviews from several directorates. The authors produced a new update of the draft and will present it today. Then we have a number of documents for which working group last call ended. The first is the backbone router document, and well, the next step here is to get the Shepherd write-up. Then we also have the 6LoW use cases for which working group last call ended, however, without feedback from the working group. So we'll have a discussion today on how to proceed with the next steps. And there was also working group last call for IPv6 mesh over BLE links. There were a number of comments on the content of the document. So the authors produced an update of this draft based on the comments. Will be presented also today. Then a few days ago, the working group last call on the address protected neighbor discovery ended as well. So we'll talk about this also today. And we have the minimal fragment forwarding document. The authors have expressed that it's ready for working with BLASCOL. And the fragment recovery document has been updated, it's in progress. And a few weeks ago, we adopted the IPv6 over PLC draft as a working group document, and it's also in progress. There will be a presentation of the updates today. Any comment? Yeah. So next, we can proceed to Pascal and the presentations about neighbor discovery related documents.
Okay, so I'll be talking about a series of 4 drafts actually. So just to give you context.
Closer.
Wow. Can I take it like this? Much better. Okay, so it's a series of 4 drafts that relate to basically unicast registration and then lookup for IPv6 addresses in order to avoid the use of reactive multicast as we know it today, which is detrimental to IoT devices, which can be sleeping or battery operated. But it's also detrimental to wireless in general over fabric. So we'll be discussing that. I'm talking about unmet expectations because between the IEEE and the IETF, there are a series of expectations, quote unquote, from the other sides that were never met. And in particular, the IETF expected that Wi-Fi would provide reliable and economical multicast services just like Ethernet. And we all know it's not the case. Multicast is not reliable because it's not acknowledged. It's also slow. Usually you have to send at the slowest speeds possible and maximum power possible. So it's very detrimental to the unicast traffic. On the other hand, the IEEE was expecting from the IETF that proxy ARP and proxy neighbor discovery would happen at the access point. If you look at it, an access point is a proactive transparent bridge. The association process is all about proactively installing the MAC address of the station into the access point so that later, when there is a lookup for that MAC address, the broadcast is not propagated over the wireless because the AP already knows that it serves this particular MAC address. So what those 4 drafts kind of do is emulate this association process for IPv6 at layer 3. But the concepts are exactly the same. Neighbor discovery and ARP are reactive. That means that when you look for a new address, you have to broadcast through the network, which is highly detrimental to wireless. The protocols that we're looking at will enable to register the address to the router, quote unquote, the access point. So this registration is pretty much a layer 3 association. And then if the registration is about getting proxy ND services, then another of those drafts, the backbone router draft, will do this proxy operation that the IEEE was waiting for. So now, after those drafts are RFC, we can really talk about fulfilling the expectations that were never fulfilled so far. So like I said, this is a series of 4 drafts. As Carlos introduced, the first of the 4 drafts, so that's the news since last IETF, it just happened right after the IETF during the IEEE meeting in Bangkok. So the 6775 update draft became RFC 8545. So that's great news. And I will tell you more about that a bit later. The backbone router, the proxy that goes with this association, password group BLASCOL. Another of the unmet expectation was the address protection. We have this savvy work, source address validation, that has been at the IETF for a long time. We know that we want to protect the ownership of an address, but CERN Secure ND was never a very efficient answer to that problem, and it was not deployed. Now we've got the new address protection work, which just passed workgroup BLASCOL, which provides an efficient solution for the savvy problem. And last but not least, we have a new draft now in this family. And the new draft is all about the activity on the backbone. Working with the IEEE in Bangkok, actually, on a particular use case, which is the Tokyo station. They call it FILS. It's really like you've got this train in the Tokyo station that empties and all those guys have their phone with them, and they all want to connect to the Wi-Fi and get immediate connectivity, because they will stay on the station for just a few minutes, and during those few minutes they need to have done everything they need to do. So you don't want to wait for that to complete after 1 second and things like that. You want to get your address immediately. You want to make sure it's unique. You want your communication to start like in less than a second, everything included. So one of the ways to improve a situation like this is to actually enable what we call a 6LBR, which is this registrar that we've introduced with RFC 6775, but also have one on the backbone itself. So it would actually serve the Ethernet people. So now you can do a lookup for a unicast lookup to that 6LBR and know which is the MAC address for that particular device. Or you could ask the 6LBR whether this address is already taken. And if it's not taken, then that is complete without waiting for a second. So this is what the last draft does. It basically propagates the concepts that we had in the wireless piece of the network in the 6LBR. We actually now place a 6LBR on the backbone, so we can avoid broadcast even on the backbone. So this is a little bit more context. This is the text of the current specification from IEEE. It's just an excerpt of what I was telling you about, that they have this expectation that we provide proxy neighbor discovery. And they say basically you have to respond to messages. Well, there is a bit more than this description to really doing neighbor discovery proxy. If you look through the backbone router draft, then you will find all the things we had to do to actually provide a good service for neighbor discovery. Now, instead of this text, now we are fighting at the IEEE to get this new text. This is the set of changes that we are proposing to the 822.11 group for their main specification. And you will see that RFC 8505 is already quoted here. And that text, actually, when we proposed it before the IEEE, had RFC 6775 update, because the RFC number was granted like on Wednesday during the IEEE meeting. So we swapped the text during the meeting itself. The first times I presented that in some IEEE meetings, it was RFC update to BRFC. And at the end of the meetings, it was RFC 8505. So that was kind of nice. And as you see, this text now has explanation on why you need address protection and you need backbone router. So you see it's a bit more text, but at least they understand that IPv6 is not IPv4. You can form address not just before the association, but during the life of the device, it will form new address and deprecate other addresses. And the protocols have to be aware of that and adapt it to this behavior, which is unique to IPv6 and different from IPv4. Okay, quick summary on RFC 8505. So you've got those three components: 6LN, which is the star for Wi-Fi, 6LR, which is kind of the AP, and the 6LBR, which is a central registrar for all the addresses. And so a wireless device will get an array. Well, actually, the AP would get the array. The AP in our case is actually a router. And the you see in 6LoWPAN, you don't expect to have multicast arrays. So it's kind of stopped by the 6LR. And what you get instead is the RS that's multicast. So the devices that comes up will multicast an RS. It will get an array unicast from the 6LR, which is the AP. And that's how it will know immediately when it wants that there is a network right there. And this saves the array broadcasts, which are mostly unused on an IoT network. And then the registration itself, which is the association we're talking about, it's this NS with this new ERO extension to the ARO option, address registration option. So that's one hop between the station and the AP, and then there is this IP message, can go as far as it likes, to the registrar, which is the duplicate address registration message that we extended, so it's either or now. So there are a number of changes to the address registration process. For the interest of the discussion today, the biggest change is that the unique ID that is associated with that registration used to be a MAC address, and it's unsecured. With 8505, we changed it to a variable size field, which can be all the way to 512 bits, and that you can, in your mind, imagine it can be a public key. So you can see already that if you transport a public key associated with the first address registration, and if the registrar stores that public key in some form, and can actually challenge later the device for ownership of the private key that goes with it, then we can actually make sure that anybody who claims to change something about an address is the actual owner of that address, right? You can see that we can prove the ownership as we need it during the life of the address. So that's this big change that we made, which used to, this unique ID, which is not represented here, but used to be a MAC address. Now it's what we call a rover field, which really means that it's ownership verifier. Okay, so that's at 505. The change that experienced the draft that experienced the most changes since last IETF, and I saw Mohit in the room actually, is the address protection draft. So this is the thing which ensures that the guy who created the address and registered the first time, so first come, first serve properties, is when things move, when the address is re-registered, maybe somewhere else, is the owner of the first registration. When you send out a packet that's a source at that address, now you can have proven that you're the owner of that address. So you cannot impersonate anybody, and you cannot claim anybody's address anymore if they're protected with APND. So the biggest change is probably the set of updates that René Strick has been doing for us. And in particular, we have changed the crypto type values. Now we have 3 of them instead of 2. So you can do many combination of the SHA, the hash functions, and the signature algorithm. Basically, there are 2 signature algorithms. It's ACDSA and Edwards. And there are 2 hash functions, 256 and 512. And two of those matches are RFCs, and one is a combination that we allow, because you may not want to have to implement both SHA-256 and SHA-512. In which case, now if you just have SHA-256, which is expensive, then you can play it with 2 different curves, whether you can use NIST or you can use curve 25/512. So that's this capability to use different sets of things so as to save some footprints, some code in your mode that we actually propose here. So 2 of those combinations are RFC and 1 is not, basically. So those 2 are RFC, and this one is kind of a mix of the 2. And compared to before, the flow is like this. When you register your address, if the 6LR did not see you before, so doesn't know that you really own that address, it will challenge you with a nonce. The device comes back with a pair of nonce, the nonce it got and insert nonce, a SIPO option, an NDP option. One of them is a signature option. So that's the second one. The first one is basically, here are the components that I used, including my public key plus other information, to build this cryptographic token that is placed in the rover field of the address registration option. So basically, I said, imagine it's a public key, it's not really a public key, there are more information stuff into it and hashed, but at the end of the day, it's as if it was a public key. And then those options basically allow you to sign something based on the private key that goes with it. But the thing that you signed as a nonce, which was a challenge from the 6LR plus a nonce that you just generated to make sure that this thing is unique. Okay. So you see that RFC 8505 created actually the changes in the arrow options to create to have this field, this rover field, this ownership verifier option, tunable in size, so we can go all the way to 512. And René actually added some text, advanced text to advance for me, so you just read it, about possible attacks and what needs to be done about this. So you've got this text in the security section of the draft. And that's pretty much it for that draft. So if you have any question, I hope I can answer. Mohit in the room, that he may answer much better than I do. And René is not there, so you have to wait for Montreal if you want to ask 2 deep questions. Okay, so let's move on.
We are running 5 minutes late.
Okay, so I'll speed.
But this draft went through the work group last call, which concluded last week. We didn't hear anything from the work group either in support or against it, but it has gone through a bunch of reviews already. So what is the opinion of people in the room about progressing this draft further? Do we need extra reviews? Do we need to go to 6-man and get it reviewed for any reason?
This one, it's more the backbone router maybe,
The option already exists.
but the APND,
APND, yes.
I think it's more the security guys, right? And we got Russ Housley providing us with advanced, the early security review. So I think we're all set. We can progress that document. The backbone router is going to be another discussion because it has more of an impact to 6-man. So maybe 6-man or India, one of those two, we could help. We could get a review or two to make sure before we press the button. But for this one, we can go ahead. I mean, we got the early security review.
Okay, so is there anyone who doesn't think that it's ready for progressing in ISG? Can we say a group last call succeeded on this draft, APND draft?
If you disagree, raise your hand.
Okay, so we think this is done. We will
Request for
shepherd it to
publication.
the next. Okay.
Okay. So the next draft is it's much thicker because that's this layer 3 access point we're talking about. This is the proxy neighbor discovery functionality. So this draft has been there for a long time. It's actually something which started when RFC 6775 started, and that was split out of it. And that was left dormant for a while and resurrected like 2-3 years ago. There is implementation. There were a good number of reviews. We went through our group last call, but we didn't go through 6-man or pre-India review. So whichever of those two might be Suresh. If Suresh is with us now, I don't know if you can hear us, but we could ask Suresh for advice on this, whether we should go to 6-man or he just names some reviewers, earlier reviewers. But I'm happy to get an earlier review before we press the button for publication. So what we do there is, so the 6LN is still the Stein Wi-Fi. The 6BBR is really the access point. So it collocates the 6LR in this case. So you do the NS address registration option, actually extended now. And what the 6BBR does is transform this unicast proactive registration into a broadcast DAD, the classical ND operation. And you have to wait for 1 second before the DAD completes, etc. So you expect the distributed reactive ND, classical ND on the right on the Ethernet side, and on the IoT/Wi-Fi side, it's going to be a proactive registration. So if you look at it, you change an SRO for association, and you change the ND here for transparent bridging, you're exactly like an association thing, but at layer 3. And that times out, you may or may not, it's not recommended, but you may or may not see an NA override at the end of the DAD. And then the 6BBR can say, yes, NA arrow. So the registration is complete, 6BBR is happy, proxy state is installed. And then when you have a data packet, if there is a lookup on the backbone on the Ethernet, the lookup will be broadcast on the Ethernet. And remember that because in the last draft we'll be talking about, it's going to be unicast. But for now, all we can do without the fourth draft is the NS lookup is actually a broadcast. And the broadcast is intercepted by the 6BBR, which splits the broadcast domain between the Ethernet and the Wi-Fi, or here it's a Ripple mesh. And because there is a registration for that address, the 6BBR will respond to the NS lookup. It may provide its own address. Typically in a Ripple network, it will provide its own MAC address. With Wi-Fi, you could also act as a bridge and provide the MAC address of the 6LN, of the star. In that case, the data would be bridged directly to the device because the MAC address that is known here is the device MAC address. But with Ripple doing a mesh here, the 6BBR will respond with its own MAC address. It acts as a routing proxy. So the packet will reach the 6BBR at layer 3, which will route them because it has a host route down to the wireless side. So both modes are actually, so you see the routed version and the switch version. The switch version, the data packet is all the way to the registering node MAC address. So in that case, this node acts as a switch or as an AP. Both modes are available. So that's it for the 3 drafts which really made a long way through this working group. Now, the interesting piece is we have a new draft. And this new draft we have actually matches a number of modern deployments that we find now in the field. The point being that we don't have a standard way to actually achieve what I'm saying, so it usually goes through proprietary implementation, proprietary protocols. With this proposal, we can make actually an extension to IPv6-ND, which makes this operation completely standard and part of the rest. So as I said, when you do a lookup and on the backbone, it's a broadcast today with the backbone router. And if one backbone router has a registration that it proxies for the address that is being looked up, then that backbone router will answer. But still, the NS lookup is a broadcast. What we want to do now is install a 6LBR on the backbone that will know which address is registered by whom. And by asking him, you may avoid the broadcast that you all see today on the backbone. And this sort of thing is particularly useful today when you have overlays. If you have a large fabric, like a corporate fabric, and you have an underlay routing and an overlay, you expect that you have a map server, a map resolver, something like that, which will tell you how to build your VXLAN or whatever encapsulation you're using. You need a resolver. And right now, you need to basically have a proprietary protocol or semi-proprietary to populate this map server or map resolver. But it's outside of the domain of neighbor discovery, and neighbor discovery cannot benefit from it. What this is proposing is that you actually use a variation of what we already have in this series of drafts to populate this 6LBR and make it completely vendor independent. So how it's done is we have a new address mapping message, and if you look down deep into how RFC 6775 did things, 6775 defined this duplicate address registration message that I showed you on the flows before. It's consuming a single ICMP type just for that. It's kind of a waste. So what we are doing here is inside this type that was reserved for duplicate address, we actually provide a new code. Remember, ICMP has a type and then a code. We actually have a variation on the code, and we reduce the type so we don't consume more space in the ICMP namespace. And we can do this address lookup as well as duplicate address validation. So this ICMP type now can do both DAD and lookup, if you like, and this is completely unicast. To enable this, we had to be able to say, no, I don't have it, so we have a new error status for not found, which was not there before in RFC 8505. And because it's a resolution, we also needed to add the source link layer address option or the target link layer address option into those messages. So it's a very natural thing to do. Remember, in ND, NS is used for that, and it's used for lookup. What we are doing now is the unicast version of that, which is the EDAR, becomes also a unicast lookup method. We do that without consuming more space in the ICMP type. We just do the next logical thing. Okay, and that's pretty much what this draft is about. What I've represented to you, remember at the very beginning of my speech, I promised you that we could consider the case of the Tokyo station and the people going outside of the train at the Tokyo station. Now I'm proving it. This is the flow. So what really happens when this Wi-Fi Fields device gets out of the train, what it's going to do is going to send an RS multicast. Or maybe somebody else has sent it, but well, it's going to send an RS multicast. Usually that's how it happens. It's going to get immediately an array unicast. Remember, the multicast is not rebroadcasted anywhere because it's between a star and an AP, and the real broadcast is always done by the AP. So whether you send that as a multicast or as a unicast doesn't matter. It's just a single packet, good as unicast. Intercepted by the access point, which is a 6BBR, never broadcasted anywhere, just answered unicast. So this does not represent a broadcast at all. So now from this array, my star as a PIO, prefix information option, I can form an IP address. Just same autoconf as before. You can use any randomization. I mean, we have enough RFCs now to do that. Now you can send an address registration option to the 6BBR. If we have this 6LBR on the backbone that I just mentioned, this new thing with the fourth RFC, then we can do another redac. If that's the only validation method that's needed, we can already know at that point that the address is not duplicate, that the traffic can start. Now, if we don't know that, we can still use optimistic DAD, which is what I represented here. By effectively having the 6BBR talk to the router and populate the ND cache on the router, if it was not already there, that's the optimistic DAD thing, then the router can go back to the 6BBR, which can go back to the star. And that's how the traffic can start right away. And you see that that timeout is a lot later. It's here. But here, what we're really doing is using RS really to populate the state in the router. And then the router doesn't have a state, goes to do an SNA. Now the MAC address is known, it's that of the 6BBR, or if we're in bridge mode, it's that of the star directly. And now the traffic can start immediately, no wait. Okay, so you see the big benefit of having the 6LBR on the backbone is this can be done completely unicast. If you don't have only this method on your backbone, you still need to do the old thing for backward compatibility. But if you have optimistic DAD, that doesn't prevent the traffic from flowing. Make sense? I know it's a complex flow, but it's basically almost immediate traffic starting. Any question? So here are my asks for this document. Really what I would like to get is some reviews because I just posted it like a month ago or two.
Any volunteers to review this? Rahul?
People care about neighbor discovery in general. It's kind of a fundamental function in IPv6, right?
Perhaps you could even cross-post this in 6man because this might have a generic applicability beyond.
It has.
So, yeah.
It has. It's designed for Wi-Fi, but it's more generally applicable.
So did you say you just posted the draft? This is Charlie Perkins. So you just posted it?
In a month ago, something like that.
And have a lot of people read the draft?
I'm not sure a lot of people are aware it even exists.
So who has read the draft?
It seems.
Dominique? I posted on 6Low, but if you missed that message, it's not like I posted every day, hey, nobody talks about it. Hey, nobody talks about it. So
Well, I don't remember too many times when the working group would adopt a draft with one person read it.
I did not ask for adoption, I asked for reviews
Okay.
right now. Adoption would be very useful. But
I'll
now
try to read it
first,
too.
Sorry?
I'll also try to read it.
So you see what we did. We extended the concept of EDAR, which is a unicast duplicate address detection, into lookup. So now we also have a unicast address lookup, even on the backbone. And if you want to scale the network, you want to allow many devices, mostly wireless devices, that's really what scales your network up. This is of importance. And yes, after that, I would like rapid adoption once I get enough reviews, because this draft is behind the others. It's way behind, and it could be good to catch up.
Okay, so thanks, Rahul and Charlie, for volunteering to review the document. It will be great if you can post your comments on the list and generate discussion if necessary.
Charlie, you're up next. Suresh is in the queue.
Can you hear me?
Yeah.
So Pascal, I just wanted to
Yes.
remind you of this draft we had together, a couple of years ago in 6man, the efficient ND stuff with Eric and Samita, and we ran into quite a bit of opposition. So, why do you think this
Yes.
draft will be different? So that I don't want you to answer this right now, but if you want to like proceed further with this, I want you to think about it. So go back and look at the objections and
Yeah, oh,
okay,
I'm
okay.
thinking about it for years, Suraj. So yes,
Okay,
we can
perfect.
talk
Thank
about it when we meet. Yeah.
So, hello, I'm Charlie Perkins. I'm here to talk about the recent revisions for the deadline draft. Well, it's really great to have this monitor.
And Charlie,
Anyway, okay. How's that? Okay, better. So this, technology. Okay, so this draft is about specifying a time when after the packet is transmitted. Oops.
Yeah, we can pass it.
Sorry about that. Oh. Okay, so this is about the draft has been around for a while and undergone a lot of comments and gone through last call and to the ISG, and we got quite many comments back from the directorate reviews, and revision 4 we believe has addressed all the comments, and there was one particular request that generated a lot of text in the draft. So I want to go through the design changes. This point of the draft is still basically the same to enable forwarding that where the packet has a deadline before which it has to be delivered, or else it can be dropped. And one of the assumptions is that the networks or the devices in the network are time synchronized so that they can tell what time it is. And there's a relatively minor operation of crossing over time zones into different networks, but we still can handle that with the mechanisms in the draft. So here's the history. It was adopted a year and a half ago, I guess. Somehow it doesn't seem that oh, there you go. That's a lot better. Thank you. So, well, I don't have to say too much about this, but we have been all along responding to comments as they were received on the draft. So now, I mentioned we had gotten reviews from various directorates, and so these are the people that submitted comments. And most of the comments had to do with the synchronization, basically. So I believe it was Dale Worley that suggested that it was sort of not a good idea to have multiple ways to represent the same time. And with the previous design in the draft, it was you could have really quite many different representations for the same time in the future. So this some of the new design is intended to address that, but also there was a discussion about how do you really know what is time t equals 0. In other words, the start time. If you, let's say you say the deadline time is 1094, well, 1094 starting when? So we were okay with the units to count the time in, but we were just assuming that the synchronization between the networks would also take care of what time t equals 0 meant. And so the new draft doesn't quite make that assumption. It's much more explicit about how choosing the different time representations affects the synchronization. So there's a whole new, so I should mention that also as part of the problem of having multiple time representations, the reviewers suggested that we should actually use an existing time representation, in particular NTP. So I looked at the NTP document, and there's a 64-bit version and a 32-bit version. The 32-bit version is derived from IEEE 1588, I believe. And so those two representations are, you might consider, standard, and they are standard. So the new deadline draft essentially uses that with a few additional ways of scaling to handle quite many. Well, it allows for transmitting the deadline time with fewer bits, and this is considered important, I think, to not always require the most number of bits for the messages that are going across with 6LO. So it was also observed by one of the reviewers that we didn't have to use the full number of bits for the origination time. We could use a delta and just have the delta be subtracted from the deadline time, because if we specify the delta, then you can get the origination time quite simply, and usually the delta is much smaller number of bits required than for the deadline time itself. So that meant that the origination time is now replaced by something called the origination time delta, OTD, and then what used to be the origination time length is now the length and number of hex digits for the origination time delta. Finally, since we didn't want to allow for so many different representations for the same time, we really got rid of this EXP field and in favor of a way of moving the binary point left or right to allow either for more integer, a bigger integer part, or more fractional bits in the fractional part. And with the NTP document, the 64-bit and the 32-bit representation had equal number of bits for the integer part and the fractional part, but with this binary point, let me see, can I point at it? There you go. The binary point allows to actually do some scaling, so you can be more precise or less precise in terms of number of fractional seconds. So with all of that, and to satisfy reviewer comments, there was a section added to the document called synchronization aspects, because this draft on NTP that was that we were suggested to follow has the recommendation to add a synchronization aspects section to the draft when you use that time representation. So that's that added up to be, in terms of total amount of text, practically all of it is in this synchronization aspects, but then there's a certain amount of modifications to the packet format to specify the new fields. And so you can see that here. Whereas the previous format had the EXP and the reserve bits, now we don't have the O bit anymore, because that meant to say that the origination time was optional, but now the origination time is going to be optional if the number of bits in the origination time delta is 0. So that means basically you aren't sending an origination time, or and you're just sending the deadline time. So the current format is down here. Let's see if I can do this. Is that red dot visible to you? How about, oh, that's better. Yeah, that was pretty, obviously I need to do that instead. So anyway, The binary point here is up to 6 bits, and that actually allows to move the binary point 32 bits to the left or to the right, and that's pretty much as much precision as you might need for that. Let's see what else. So we have, and now instead of bytes, these are counted in hex digits. So that's a little bit, it allows for somewhat more compact representation. All right, so here's an expanded version of what I just said. And I don't think I need to say it all again, except I'll just mention that this destination time length is actually the number of hex digits. You should add 1 to it. That allows you to have destination time length 0 to actually mean something. So you add 1 to the value of this 4-bit field to get the total number of hex digits that are allowed to be used in the destination time. And then that can give you a quite wide range of numbers. So that's it. Any questions? I hope it at least made some sense, but I'd be delighted to take offline questions as well.
Have you reached out to the reviewers since they are from different areas with the revised version of the draft, and how you address their comments?
Well, we just submitted it, I guess, about 3-4 weeks ago, but you're right. I should actually solicit feedback from the reviewers. I will do that. Okay. Yes, Pascal.
Pascal Thubert. Charlie, I think the answer is no, but I've not read the latest version. I'm sorry for that. At some time during the inception of this document, because you just mentioned, the reason why I'm asking is, you just mentioned the forwarding activity based on this option, right? My understanding is the forwarding activity based on that option is drop or not dropped based on the maximum delay for this packet. Do you have any other activity in the forwarding? Because I see a lot of power in that option, and I'm disappointed that the only thing we do is actually drop or not drop the packet.
Right. So this is about the D-bit. The D-bit gives you the option of not dropping the packet, even if it's past the deadline. And there's some text in the draft that says why you might want to do that and circumstances under which you should not forward the draft when, even if you had the option to do so.
But what I'm really asking is, there are forwarding decisions that could be made on that options beyond the dropping decision, and one of them is quality of service.
Right. So that's right. So I mean, and we can, if you want to
expand
on that in the text, I mean, in the document, I would be delighted to get suggested text from you.
Okay. Okay.
No, but that's Pascal. That's the scope of the document is a deadline time, right? So do you really want to expand the scope to include other policy actions that can be taken based on this?
Yes.
Or should it be a separate draft?
Okay. Okay. Works too.
Oh, and one thing I want to mention, I regret to say that I forgot to include some of the reviewers in the acknowledgement section, but I'll take care of that.
Hey, Charlie, this hex digit thing is a bit confusing. I would recommend you use nibble instead, because the nibble is a 4-bit thing. So you can say like, number of nibbles, like -1.
Oh, well, I'm delighted to hear that because I like nibbles too, but I was told that hex digits was better.
Sounds good, thanks.
So I'll use nibbles, no problem. Okay, we're all hungry. Thank you.
Okay, so next
Use
is
case draft.
use cases draft.
Okay, thank you. Hi, this is 6-row applicability and use case document, and my name is Yonggun Hong. So, in this document, there are lots of the authors. So, I'm the author of the PLC or NFC document, and Carlos Gomez, he is expert in the Bluetooth and Bluetooth mesh. And Yohan Choi is expert of NFC, and AR Sangi is the expert of the PLC, and Tech Anashut is expert of the MSTP and 8.15.4 technology, and Samita also involved in this document. So the many experts, including the 6-row technology, are involved in this document. So yeah. And this is the 6th version. So the working group adoption was done in 2 years before, and this is 6th version. And the goal of this document is to help 6-row PAN stack adaptation by layer 2 constraint technology, and help a newcomer understand how 6-row PAN stack can be applicable in practice. So we hope this is useful for new adopter of IoT. So I know that the 6-row experts don't have any interest about this draft, because you know very well about the technology, but newcomer have some difficult. What is the 6-row and how 6-row technology could be applied in the real field? So update after the last meeting. So the working group last call was done in this 2 weeks by Gabriel Montegro, but unfortunately there are no comments. So I think that document means that it is a good document, and so there are no missing point, or there are no interest about this document. So I'm not sure. So anyway, there are no comments in the working group last call in last November. Even though I update the draft because one of the 6-row technology document, the PLC document, become as a working group document. So I apply these changes, and another references, for example, NFC document, it become the 13th, and it is in the IS evaluation, and every energy efficient document become RFC document, and other low and 6-row barely missed document, they change, so I reflect these changes. Okay, this is the next step. So in my side, in this draft, there are 4 6-row deployment scenario in the real field. One is that is Python mesh, YSUN, and G3 PLC, and Netricity. So among them, I heard that Netricity is moving to from HomePlug Powerline Alliance to YSUN Alliance, but until now, there are no official announcement. So I'm double checking about this change, but there are no official announcement. So if some change about Netricity is happen, then I will update. Yeah, so it is my inside next step, and I would like to ask other person to review this draft, and it is very, very appreciated to give us your comment. What is missing point, or what is the long text about 6-row technology, and what we need more, what we need more to deploy 6-row technology in the real world. Okay, that's all.
So what should be the next steps? Given that it's a living document, do you want to publish it as an informational draft, or should we do something like keep it in the 6-row wiki, and so that anybody joining the 6-row work group could make use of it? What are your thoughts on progressing this with a reference in the wiki, the data here?
May I ask what is the 6-row wiki?
Sorry,
What's the wiki?
Yeah, well, at least the 6LO working group has a wiki.
Yeah, yeah.
So it is assumed to be a place where different resources, information about the working group activities can be found. So, well, that might be, well, one resource where people looking for what is 6LO, they might find important information within this scope.
Okay, it could be, but I would like to develop and make a progress of this document based on the other expert comment, if possible. So, do we need more time? Then I can wait more. Okay.
Pascal Thubert again. I'm just curious, what do we expect from 6LO in the future? And it's probably a question to the chairs, but do we expect that we'll onboard new technologies? And I hope so. And if that happens, then probably it's cool to keep your document open, till the group ends, pretty much.
Well, basically speaking as a co-author of the draft, I would like to know how to understand the silence during the working group last call. What does it mean? Does it mean lack of support? Does it mean maybe anything else? That's my point.
So let's defer to our AD for guidance. Suresh, what are your thoughts on next steps for this draft?
I'm not sure about the archival value of this draft. Yeah, I'm not sure about the
Suresh,
archival
could you
value of
repeat
this draft, and that's why I was a bit concerned that we are going for RFC. And second thing is the scope of the draft, which I'm not sure about as well. So I think the scope is like pretty big for this draft. So I think if we decide to go for publication, I think we need to probably chop down a bit. Did you get that? Sure.
Can I answer? Okay, thank you, Suresh. Yes, I got your point. Okay, then I will discuss your comment with the author of this draft, and we had a better focus on the narrow scope and more concrete scope. Then after that, we will make a revision and then waiting for more comment about that. It's okay?
Thank you. Thanks, Suresh.
Okay, hello. I'm going to present now the last update of the draft entitled IPv6 Mesh over Bluetooth Low Energy using IPSP. So first of all, let's take a look at the status of the draft. There was a working group last call on the previous version of it, which was 04. Then there were a number of comments received, and some of them included actual comments on the text of the document. These were the comments given by Bill, Rahul, and Pascal. So thank you very much to everyone who provided feedback. And as a result, we updated the document. We released version 05, which we understand addresses the working group last call comments. So at this moment, we believe, the authors believe, that the document is ready for the next step. Okay, now let's take a look at the updates in this last update of the document. First of all, there was a comment by Bill related with one of the terms used throughout the document, which was different variations around the term IPv6 mesh over Bluetooth LE links. So we are using this term, but in different forms. So now we have stuck to the form that you can see on the slide, and we now use it consistently throughout the whole document. Then there was a comment by Rahul that perhaps it was not clear for the reader whether this document is sufficient by itself to enable IPv6 mesh over BLE or not. So now we've added in the abstract and introduction also, we've tried to clarify that the document is not sufficient by itself. So we now explicitly state that the routing protocol is not specified. And also we've changed the wording of some sentences. We used to say something like specifies the mechanisms that are needed to enable this. However, we have now removed the in the mechanisms. So it's clear that this document is needed, but it's not sufficient by itself. Well, then there was another comment by Bill, who pointed out that Bluetooth 4.1 has now been deprecated. So we added Bluetooth 4.2 as a normative reference, and Bluetooth 4.1 is still a reference in the document, but it's now an informative reference because the text that explains that Bluetooth 4.1 was the first specification allowing extended network topologies beyond the star topology in Bluetooth Low Energy, that is still true. Next, please. Then, after a comment by Rahul, we realized that we were missing an important point in the document in section 3.1, which discusses the protocol stack. For us, the authors, it was quite clear that regarding fragmentation, we would use the same approach as in RFC 7668. However, we didn't explicitly indicate it in the document, so now we have added a discussion on the MTU and fragmentation. We explained that in Bluetooth 4.2, the link layer MTU, meaning the maximum size of the payload at the L2 cap layer, which is the layer below the adaptation layer, is 247 bytes. And also we add that in previous versions, Bluetooth 4.0, 4.1, the link layer MTU was 23 bytes. And we explained that in this document, as we did in RFC 7668, we use the fragmentation and reassembly functionality that's available provided by L2CAP. So there is no need to use the 6LoWPAN fragmentation functionality here. We also add that the IPSP allows negotiating link layer connections with an MTU of 180 bytes for IPv6 in order to comply with the IPv6 MTU requirement. Thank you. Then there was a comment by Pascal, and we updated the neighbor discovery section because formerly we referred only to RFC 6775, sorry. So now we include as well RFC 8505, and we consider the formats and the mechanisms that are included also in 8505. And for example, we now talk in terms of the extended address registration option. Now we also talk about the rover, and we explain that by default, this field is based on the Bluetooth device address, but we also explain that optionally, a crypto ID may be used instead, such as the one in Pascal's draft of address-protected neighbor discovery. In addition, we've also prepended as per RFC 8505 to the sentence, a 6LN must not register its link local address. And, well, sorry. Yeah. Also related with these comments, we have updated the security considerations. We now explain that address theft and impersonation attacks may happen when Bluetooth device, when the rover is generated based on the Bluetooth device address. So we explain that the specification of the address protected neighbor discovery gives protection against this kind of attacks. So yeah, basically that's all. I don't know if there may be any questions or comments.
So does it address all the review comments that have been raised so far? Do the reviewers have any further comments on the new version of the draft? Are we ready to progress it in ISJ in that case? Okay. There's a lot of nodding instead of humming. Okay.
Okay, thank you very much.
Thanks. Thomas? Yeah.
All right, good afternoon. So I wanted, is this on? Yeah. Okay. Hello. So, well, this is really low. I wanted to give you an update about the 6-low minimal fragment draft that I've been co-authoring with Karsten and Pascal, which is now in version 01. Next slide, please. Oh, can I have this clicker?
Yeah.
Thank you. So these are slides that I've been picking from different presentations that I've been given on the subject, and so I'm trying here to summarize what fragment formatting, what nuclear fragmentation is so far. So in RFC 4944, the RFC 4944 defines fragmentation header and tells you basically how to cut a packet into little fragments and send it over to the next hop. And there is a reassembly timer that indicates when that next hop needs to clear those the packets being reassembled. And so there's a reassembly that happens at every hop. 6282 does not change that, so everything that's in 4944 is still valid in this case. And so we've been looking at the problem that is that per hop fragmentation or reassembly is problematic. There are two main problems with that. The first one is latency. So the problem is basically mode A sends little fragments to mode B, and mode B can only send to mode C once it received the last fragment from mode A. I hope I didn't get stuck in the numbering there, but that's the problem. Latency is pretty high, and reliability is probably the most problematic of the two problems. Because mode B is reassembling, it only has limited amount of RAM to do that reassembly, and so it cannot be reassembling many packets at the same time. And so as it's reassembling the second packet, when it gets a fragment from a third packet, it has no option but to drop that fragment. And basically that third packet is being lost. And I'll show you a little bit later results that show you that this is true. And so the proposed solution for this is fragment forwarding, where only the source node cuts the packet into fragments, sends the fragments across the network. Intermediary nodes that are relaying the data relay the fragments without reassembling, and it's only at the very destination that we do reassembly. And so you have in the network, you have little fragments flying left and right that are not being reassembled until it reaches the low power board router. So in IETF 101, we created the 6-low fragmentation design team that is now closed. And it's closed because the three following drafts that it has generated were adopted by 2 working groups. There is 2 drafts in the 6-low working group and 1 draft in the LWIG working group. And the way this works is that the draft I'm talking about is the first one, which gives you an overview of 6-low PAN fragmentation and highlights the limits of virtual reassembly buffers. That is the mechanism that's being defined in the second draft, which is an LWIG draft, which Karsten is leading. I don't see Karsten. And then Pascal has defines a new protocol which does fragment recovery. So in case a fragment gets lost, these 2 first drafts do not do anything about it. Basically, a fragment is lost, and now you have to resend the entire packet, which in some cases is okay if the probability of losing is very low. But if the probability of losing is pretty high on a fragment, then it makes more sense to have a new protocol to do recover individual fragments, but to have to retransmit the whole packet. So this is the status of. So this was a long intro for this draft. Basically, you see, I did minimal changes, so I populate my 10 minutes with context. So the last slides are actually what I did. So on 11th of March, I posted a 1. It's an informational draft which really describes the problem. It doesn't provide a solution. It's the LWIG draft that provides the solution. So here's the table of contents, and the changes in 01 is very small. Fixed some typos, and I put a link to a study that Yasuyuki Tanaka, who's sitting there in the back, has done. He has been simulating this using the 6-dish simulator to show that yes, indeed, there's a problem, and yes, indeed, the resolution proposed in Karsten's draft solves it. And these are these are the results of that. So Yachai created those slides. Please shout if I'm misinterpreting your simulations. So here you have a little network of nodes that send data up to a root node J, and node I here is an exposed node. There are multiple flows going through it. And so using the 6-dish simulator, we're able to show that if you're just using RFC 4944 per hop reassembly, the more fragments you have in your packet, the more likely your node I here will be to drop some of these fragments and hence drop some of the packets. It's trivially simple to understand. It's just graphs to back up, the claims. But basically, what we see here is that as we have the number of fragments increment, the overall end-to-end reliability drops down. Whereas if you don't do reassembly at every hop and you keep forwarding the fragments, you don't basically you're not losing any packets because of this mechanism. And the nice benefit, of course, also is that the RAM footprint of doing this, so the amount of memory that you need, is much lower if you do fragment forwarding than reassembly. So I believe, so my question to the working group is, this draft has been stable, it hasn't really moved since the last IETF. And so I haven't seen any complaints about it. I don't really know what I would change, so I'm asking the working group whether we're close to working group last call.
Okay, are there any comments on the document at this point? So I guess we can open a working group last call, and it would be great if we could have maybe 1-2 reviewers. So who would like to volunteer to review this draft?
George. And Dominique.
Thank you very much.
Thank you.
So thank you, Thomas, for the introduction, so I don't have to reintroduce again the problem. So basically, we see that forwarding the fragments alleviates the problem of buffer bloat in individual nodes and improves the streamlining of the fragments, so the final destination is reached faster. What it does not address is the classical case of one fragment that's lost. And if one fragment is lost, then the buffer is locked basically on the receive side until some kind of timeout. And during that time, the buffer is being locked, the device cannot do anything else. And this has been shown actually to reduce dramatically the throughput of IoT networks. And that's even the reason why the first SNMP implementations happened in those modes, to figure out why the throughput was so low. And in reality, the throughput was so low because fragments were being lost, buffers were being blocked, and then all the other packets were being destroyed because there was no room for them. So that's why we started this effort of selective fragment recovery, which is basically a principle that has been used since in SCHC, and SCHC is already through LASCO, and this thing is not yet. But basically, the idea is pretty much the same. You send your fragments, you have an acknowledgement bitmap, and based on this acknowledgement bitmap, you resend selectively some of the fragments. It's not rocket science. It's not necessarily easy. We saw in LP1, but not necessarily easy either. To do that, we had to introduce a completely new scheme for presenting the data. So we could not basically be backward compatible with RFC 4944. We had to have new formats and everything and new operations. The operation that we introduced enable a bit of flow control, which cannot be done without it, and also also provide a bit of ECN. You have an ECN bit, which is pretty much the explicit congestion notification that you're used to at layer 3, but it really happens between the 6-LoWPAN sublayer and layer 3 as opposed to layer 3 and layer 4. But it's still a congestion notification. That way, even with the streamlining that we just saw, if you may still have congestion in some nodes, and we'll be able to slow down the emission of the fragments to reduce the chances that they're destroyed. So what happened? Well, what happened is we got implementations. That's what happened. That's pretty good. And so we get commands from implementation and from the real world. And as it goes, the commands from the real world were that the formats that we had did not really enable some use cases like very large frames, for instance. Very large frames fragmented in many, many fragments. We could not even address that. We didn't have enough datagram tags in our formats. So we actually modified the formats. And what we did, well, I'll show it later. What we did is we have reduced the size of the datagram tag because there are not so many datagram in flight between a source and a destination. So why should we have so many, like 64,000 possible datagram tags in the air at the same time? We reduced that from 2 bytes to 1 byte. And with the bytes that we saved, we could actually have larger datagram sizes and larger offsets. That's pretty much what we did for this discussion that we had. And with this, Michel Veilletis was capable of implementing the real-world use case that he had. The other modification was the prime of the slack in the first fragment. The prime, when you recover fragments with just 1 bit saying this fragment was lost, send it back, is that you cannot move the boundaries of the bit of the fragment because you will resend only that particular fragment. When you don't recover the fragments as we do, so with the original fragment forwarding draft that Thomas presented, it doesn't matter if what you output is the same thing as what you input. You might keep a few bytes in memory that you will append to the next fragment. That's perfectly okay. But with the fragment recovery, you must basically provide the same fragment out as you had in. And remember, 6LoWPAN may actually, the efficiency of the 6LoWPAN compression might actually change if you're the originator of the packet, the receiver of the packet, or an intermediate node for that packet. So we had to provide some room in the first fragment where 6LoWPAN compression happens so that you might actually change the way the IPv6 header is expressed by 6LoWPAN without changing the boundary of the next fragments. Okay. So that's this text which we kind of improved to say that, but that was there. The other thing which Michel pointed out is, okay, but if you change the first fragment, it means that the offset of this datagram, of the modified datagram in the packet, in the compressed packet, which is how we express things here, changes as well. Yes, it does. So if we introduce some new bytes, for instance, in the first fragment, that means that the offset of the second fragment in the compressed form is actually offset by that much, by those bytes that you introduced. So you have to remember, as you forward the fragment, when you introduce some bytes or reduce the size by some bytes, you must remember that delta, and you must apply it to all the fragments that come next. So we actually provided some text to say that. But remember, it's important that the boundary of a fragment, like what it means, first byte, last byte, are the same all along the path, because that's what's going to be retried. So this is pretty much what is being discussed. If the second hop has a less efficient fragmentation, needs to add like 5 bytes to the first buffer, we need some slack to have this room, one thing. And then we need to remember we add 4 or 5 bytes because the datagram size is changed. And the datagram offset of all the further datagrams is also changed by 5. It's pretty much what we indicate. And there is the new formats and the change of formats. So as you can see, the datagram tag, which was 2 octets, ridiculously long, because it has to be unique for a source anyway. So it is reduced to 1 byte, which allows us to have a wider field for the fragment offset and for the fragment size. And with that, we're able to implement use cases in 15.4G, where the frame can be 2K bits, 2K bytes, I'm sorry. And now we can support all those. It's pretty much the news. So it's implemented. Implementers are happy with it. Same question as Thomas, are we ready for World Group Last Call? there anything else that people would like to see in this draft that's not there?
Tout à l'heure, just a question about why don't you use SHIC fragmentation? What are the reasons you have to do this mechanism?
Excellent question. This was there much before SHIC compression, actually. So why didn't SHIC use that? Actually, I would love to have reviews by the SHIC authors. And the mechanism is not exactly the same thing. For instance, I mentioned the forwarding because SHIC is just hub and spoke. So you don't have the concept of forwarding across multiple hops. So you don't have the kind of problems I'm discussing here, like changing the datagram offset, etc., etc. You may have many datagrams in flight from many sources to many destinations. So, but the global idea of having a bitmap which index, the missing fragments is the same. So that's why I would appreciate that the SHIC authors of the fragmentation, and hey, I have two people in the room that can't decommit now, if they say yes, would actually review this thing. I think that if you two guys give me a good review, we are ready for last call.
Okay, so I guess Laurent agrees, so I also agree. Thank you.
Okay, good afternoon. I'm Romeo from Huawei, and I'm the co-author of this IPv6 adaptation for PLC network draft. So let's first review the history of this draft. So why we wrote this draft? Historically, PLC power line communication has been widely used for metering, but now people have more expectation more than that. People are using PLC to transmit IPv6 packets for more applications than metering. For example, to control the traffic lights, to transmit the control commands for in the smart grid, something like that. And so we need IPv6 adaptation layer for constrained PLC because historically only for metering maybe the layer 2 is enough, but now we need to transfer it to layer 3 now. So for this draft, the scope is the constrained PLCs, which have the constraint bandwidth, constraint bit rate. So what is in the scope is the ITU-T G.9903 and IEEE 1901.1 and IEEE 1901.2. So this draft started at March 7, 2017, and it is adopted by 6.0 in February. And during the adoption, we have received many support, but in terms of comments, we have received only one from Cousin. And in Cousin's opinion, that there may be some misleading or confusing landscape about PLCs because in section 3 it mentions about IEEE 1901.1 and G9904. But we did not mention this. We do not mention this kind of PLC technologies in the rest of the draft. Before we resubmit this draft as the working group draft, we have added some clarifications to clarify the scope of this draft. And in section 3, we tend to give a whole landscape about the PLC technologies, including the broadband technology as well. So, but it is not in the scope of 6.0. So we have added some clarification to say that we will be only focused on the constrained PLCs. which is already included in this draft. So for the future work, we will reference more to about the header compression. We will add more content instead of just a reference to RFC 4944 and RFC 6282. And we will also add some reference and related description about the 6LoWPAN routing header, something like that. And maybe you can give some comments about this draft and some for our new versions. And because now it is the working group document, it belongs to the group now. Okay, thank you. Any comments for now? Okay, thank you.
Well, maybe one question. Are you aware of any implementation initiatives?
Yes. In our company, there is some implementations and in our actual product about the IPv6 over PLC.
Yeah, that's great. So it would be good to improve your document based on implementation experience to see whether there may be potential issues and so on.
Okay, okay, I will do that. Okay, thank you.
Thank you. Wiki. Do you want to do it? Or yeah, whatever. Okay, so now the last item in the agenda, the one we have added at the beginning during the agenda bashing, is about the 6LoW Working Group Wiki. That is a resource that has not been updated for a while. And one idea that we had and also was suggested by the former chairs was trying to get the wiki up to date. So it would be great if we can, the working group can provide content to populate the wiki. And in this regard, it would be great if you can provide us details, pointers to things like open source implementations, interop events, and maybe other additional related information. So if you have any details like this, please let us know, and we'll try to see how we organize updating the wiki. Okay, are there any other comments?
Has everybody signed the blue sheet?
Yeah, please sign the blue sheets. So if there's no other comments, the meeting ends at this moment, and see you all in Montreal. Thank you. Where are the blue sheets?